Okay guys, in this video we are going to prove that if a is an integer, then 3 divide a times 2a squared plus 7. So I want to start with the division algorithm. So let's start with this. So we gotta let a to be an integer, and then we will use division algorithm. So we have to consider integer a, and I want this to consider a and 3. Okay, because because we want to show that 3 divide a times 2a squared plus 7. So by division algorithm, so we gotta have okay, I forget, the axis q and r, the axis integers q and r, such that a equal 3q plus r, where r is an integer that is greater than or equal to 0, less than absolute value of 3, which is 3. So that means that we gotta have 3 cases for a. So we gotta have a equal 3q in the case where r is 0. Another case, the case where a equal 3q plus 1. And the last case, the case where a equal 3q plus 2. Okay, so we split into 3 cases. So we start with the first case, the case where a equal 3q, where q is an integer. So I want to start with a times 2a squared plus 7. So we start with the dividend and we substitute 3q into a. So we gotta have 3q times 3q squared plus 7. And then we gotta have 3q. And we have 9q squared inside, so we gotta have 18q squared plus 7. And factorize 3, we gotta have 3 times q times 18q squared plus 7. And we know that this product is an integer. Okay, so that means that 3 is a factor of a times a squared plus 7. So we have shown that 3 divide a times 2a squared plus 7 by divisibility. Now let's go to another case. The second case, the case where q or a equal to 3q plus 1. So how can we do with this case? For this case, it's similar to the previous one. We want to start with the dividend here, which is a times 2a squared plus 7. So it turns out to be 3q plus 1 times 3q plus 1 square plus 7. Then we gotta have 3q plus 1 times 2 times 9q plus 9q square plus we factorize, we expand this term. So we gotta have 6q plus 1 plus 7. Then it turns out to be, okay, let me write down here. So we gotta have 3q plus 1 times 18q squared plus 12q plus 2 plus 7. This distribute is number 2. Alright? And then we gotta have 3q plus 1 times 18q squared plus 12q plus 9. So 2 plus 7 is 9. As we can see, we can factorize number 3 out of this term. So we gotta have 3 times 3q plus 1 times 6q squared plus 4q plus 3. And this product is an integer. That means that we're going to have a times 2a squared plus 7 equal 3 times some integer. So we have shown that 3 divide a times 2a squared plus 7 in this case. Let's go to another case. The last case is the case where a equal 3q plus 1. The case where a has the remainder of 2 when it is divided by 2. So let's start with a times 2a squared plus 7. And we plug in 3q plus 2 into a. So we gotta have 3q plus 2 times 2 times 3q plus 2 squared plus 7. So we gotta have 3q plus 2 times 2 times 9q squared plus 12q plus 4. Okay, what can we do next? We try to simplify this term. So we gotta have 18q squared plus 24q plus 8 plus 7. We add all the terms. So we're gonna have 3q plus 2 plus 18q squared plus 24q plus 15. As we can see, this term right here, we can factorize number 3. So we're going to have 3 times 3q plus 2 times 6q squared plus 8q plus 5. And as we can see, this is an integer because q is integer. So 3q plus 2 times 6q squared plus 8q plus 5 is also an integer. That means that 3 is a factor of this term. So this means that 3 divide a times 2a squared plus 7. So from all of these terms, from all of these 3 terms, we have shown that if a is an integer, then we can conclude that 3 divide a times 2a squared plus 7. Okay? And that's it for this video.